This module is almost done, but we're going to make one final comment on the ANOVA F test. The ANOVA F test does not provide any insight into why the null hypothesis is rejected. It does not tell us in which way the mu's, the population means, are not equal. We don't know which one was larger or smaller than a different one, which is a bit disappointing. Obviously, we want to know which pairs of mu values are not equal. If the ANOVA F test suggests that there is at least one mean that is not equal to the others, in other words, we accept the alternative hypothesis, then we can look at confidence intervals to estimate the population means, mu1, mu2, on and on, all the way to the last mu, and look for intervals that do not overlap. When two confidence intervals overlap, then it's possible that the two population means are equal. So for example, if this is one confidence interval for mu1 from left to right, and then the confidence interval for mu2, that just means mu1 is in this interval somewhere. We don't know where. And mu2 is in this interval somewhere. It could be that they're on the same exact level because those intervals overlap. So there's an overlap in plausible values. When two confidence intervals do not overlap, then it's possible that the two population means are not equal. And it's often what we can assume. But these are confidence intervals, are not exact. We think that they're not going to overlap. It's possible that these intervals do not actually contain the mu's. Depends on the confidence level. So for this, in this example, mu1 is in this confidence interval somewhere. We're like 95% confident that it is, or whatever the specific percentage is. And then same for mu2, that we think mu2 is in here somewhere. We're 95% confident, or some specific percentage. Those don't overlap. So if mu1 truly is in this interval and mu2 is truly in this interval, they definitely are not the same value on the x-axis. Even if mu2 is the very leftmost value here and mu1 is the very rightmost value here, they're not the same. They're close, but they're not the same. However, this is only an exploratory investigation to get a sense of why the null hypothesis was rejected as a follow-up to the ANOVA. It's not a formal inference method. These confidence intervals do not definitely determine which of the population means differ. There are more sophisticated statistical techniques called multiple comparisons that are better for making this determination. But we will not study these techniques in this introductory statistics course. You might see it if you have to take another statistics course in the future. But let's go back to that example of frustration level in your major, depending on if you're the English, math, psychology, business. Consider our first example that investigated the relationship between major and level of academic frustration. We conducted an ANOVA F test, and the outputs were below. We saw that the F statistic was 46.6 or thereabouts. The p-value was very small, less than 0.0001. So based on that small p-value, we rejected the null hypothesis and concluded that not all four frustration level means can be equal. In other words, that frustration level is related to the student's major. But we didn't really know which of the majors had the frustration level on average that was higher or lower than the others. To get more insight into that relationship, we can look at the confidence intervals marked in red. So notice that the English majors, their confidence level and mathematics and psychology were all fairly close together. I could see there being an overlap maybe, but the business majors were much farther to the left. So that's probably the one that was not equal to the others. Probably, we're not for sure, but confidence intervals are, you're a certain percentage sure that your mu is in there. So I'm like 95% confident that business might be the one. Note the following about these 95% confidence intervals. First, the confidence interval estimating the mean frustration score for all business majors is lower than and does not overlap with the other three. This suggests that business majors may have a lower mean frustration level compared to the other majors. We're not for sure on that one, but we're pretty sure that that's probably what it is. That's the most likely scenario of why the null hypothesis was able to be disproved. Secondly, the 95% confidence interval estimating the mean frustration scores for all English majors is lower than and does not overlap with psychology confidence interval, the second and the last ones. So it looks like the math, let's see, I'm going to erase this so we can see the math confidence interval kind of overlapped with the English one and the psychology one. But if you just look at the English one and the psychology one, they don't overlap on the x-axis. This is the end of one and the beginning of the other. So this suggests that English majors may have a lower mean frustration level compared to psychology majors, because we're pretty sure the mean frustration level for English majors is in that confidence interval somewhere. And the mean frustration level for psychology majors is in there somewhere because they don't overlap. Their mu's can't be the same. It must be that the English is less than the psychology, as long as these intervals are pretty accurate. However, as we noted earlier, this is only exploratory investigation to get a sense of why the null hypothesis was rejected. These confidence intervals do not definitely determine which of the population means differ. There are more sophisticated statistical techniques called multiple comparisons that are better for making this determination, but we won't study those techniques in this introductory statistics course.